Well, welcome back to Hillcrest Energy Technologies, a channel with energy solutions powering the future. To discuss kind of the in-depth idea of these inverters and the technology they're forefronting, we have the Chief Commercial Officer, James, joining us today. Welcome, sir.
Thank you for having me.
It's such a pleasure to get you on. So I really want to kind of refine this down for somebody that might just be stumbling on as either a viewer or an investor, but you do have this incredible technology in with these inverters. Do you want to kind of explain what an inverter is and what it does first and foremost?
Sure. So an inverter in really simple terms is a signal converter. So if you have, most people have heard of DC power or AC power. An inverter basically converts one into the other. That's a very simple way of looking at it.
Yeah.
And if you look around the world, inverters are everywhere. So you need an inverter to take battery power and convert it into AC power to drive a motor in an electric vehicle, for example. You need an inverter to connect a solar farm to the grid from DC to AC, for example. And then there are millions of examples. Inverters are everywhere. Every pump, fan, compressor in an industrial application, there are inverters everywhere in one form or another.
Yeah, and I think people don't appreciate too at scale. We kind of look at the broader picture of just the electrification of vehicles and wind and solar, but we don't appreciate the individual parts, the manufacturing, and all these subtle things that have to come into play that have huge ramifications on the inputs and outputs and how this strains the grid and everything in between. But these inverters, though being everywhere, do you want to talk about what makes yours so specific, how these are offering efficiencies, and why it plays into the current electrification of things?
Sure. So that's a great way to ask it. So electrification is obviously increasing the need for inverters, more places, places where they weren't that important before. So the obvious thing that everybody's looking for is an inverter that's got a good combination of efficiency, performance, reliability, and cost. So inverters are good devices today, but with the amplification of use and larger loads and larger applications, those things become that much more important. And a good example is electric vehicles. The manufacturers are under a lot of pressure for cost, and so they need to find ways to do this, and at the same time reducing cost. So that's where Hillcrest technology comes in. This is not a small incremental change in the combination of those things. It's pretty big. So effectively, what the Hillcrest technology does is it eliminates all of the switching losses associated with inversion. So let me just explain that. So an inverter basically is sampling the signal and converting it into a different waveform. That act of sampling is kind of, let's call it switching. Switching is the common term used for that. And in the process of doing switching is where you incur losses. And there are two kinds of losses: switching losses and then conductive losses. Conductive losses are just, wires heating up and things like that. Switching losses is the actual act of sampling the signal and pulling it in. And so the big thing with Hillcrest technology is all of the switching takes place in a de-energized state. So what that means is there's no voltage or current load on the switch when that actual activity is happening. So what that does is it completely eliminates losses associated with that activity. And that's a big deal. That's 55 to 60% of the losses that remain in that process. So there are two big sources of value that come from that. One is the actual increase in efficiency in the inverter itself. But the way Hillcrest does this produces a signal that's so clean and consistent with almost no overshoot or oscillation or harmonics, um, which basically means that everything downstream of the inverter benefits. So motors last longer and like the signal better. You need less inductors and capacitors to manage that signal downstream. You get less EMI. You get less harmonic distortion. All of these things that have value beyond just straight efficiency.
Yeah, I definitely appreciate the insight on that. Do you mind talking about where you're kind of operating with these? You guys kind of coming out of test phases. What's the kind of the the sector focus to begin with, and how do you plan on scaling this? What should investors kind of focus on in 2024? What do you see happening?
In 24, there'll be two major things. One is we're going to be moving quite a bit further down the road with the electric vehicle path, which was started some time ago, and now we're getting into some really good deep levels of engagement with customers. So we're doing specific development for customers in 24. So you'll hear announcements, that'll reveal what we've done. And those are moving us down the path to commercialization in that application area. You'll also hear things about stationary applications or grid connected applications. They're not all grid connected, but they're not EV. Things like industrial drive motor control applications, connecting solar farms to grid, working with wind turbines for um, motor control slash power factor correction type things, which people don't need to worry about too much. But there's definitely an application there where the same attributes that we see manifesting themselves in automotive will show up in slightly different ways, but very parallel in the other applications. So efficiency, better signal, harmonics reduction, all of those things. So it'll be a new area that you'll hear about more in 24.
Well, let's look forward to, and I appreciate all the insights today, James. And I'll pass it off to the viewers as news and catalysts come into play. And you guys want to learn more, consider hitting that subscribe button for those updates. But on that note, as always, we look forward to catching you in the next one.